The tropopause. In an earlier video, we looked at the idea of the tropopause as a boundary between the troposphere, where all the weather that we're interested in occurs, and the stratosphere. And what's shown here is an aerological diagram. That is a diagram where we might represent the temperature structure of the real atmosphere and its moisture profile. And we have two balloon flights. The red flight is from 23 UTC, or 10 AM, summertime, on the 3rd of February 2005, and the blue line represents the same profile but a day earlier, on the 2nd of February. On the left of the figure we can see profiles of the moisture, but we won't consider those for now. Let's just look at the temperature profile. So you can see today this region here at 38,000 feet, which is the standard way of measuring height in meteorology, is where the tropopause begins. The day earlier, the tropopause was at 33,000 feet. The tropopause is defined as a region where the temperature stops decreasing with height and is either constant, as it more or less is here, in which case we call it isothermal. Iso meaning same and thermal meaning referring to temperature, so it's the same temperature, or a weak inversion, as discussed in an earlier slide, where the temperature actually increases with height as it does in that layer. So the tropopause is essentially an inversion which acts to limit vertical motion in the real atmosphere, and we'll look at that later when we consider deep convection. If you look at the tropopause height, you also see that it varies with latitude as well as temporally at a fixed point. So the figure in the top left here shows the mean tropopause height over the full range of longitudes for a given latitude, and you can see that the tropopause is lowest in the polar regions and increases quite rapidly, and highest somewhere near the equator here. Remember, the tropopause is this thin region between the troposphere and the stratosphere. That's shown as a map here on the right, which is the monthly long-term mean between 1968 and 1996, and it gives the pressure in millibars. We'll talk about pressure units later, but millibars is the same units as hectopascals, which is the standard pressure unit used in the Bureau of Meteorology. And what you can see is that the height of the tropopause is pretty much constant through much of the tropics, between about 30 south and 30 north. There's a very strong gradient in what we refer to as the mid-latitudes, between about 30 and 60 north and south, and then the high latitudes it's pretty much uniform again as a minimum. Here's a question for you to ponder. Why is the tropopause higher in the tropics compared to the mid-latitudes or the polar regions of the atmosphere?